All right, hi everyone. We're going to be looking at logic gates again today. Okay, and today is our last session on this entire syllabus. But we're going to be specifically talking about the applications of logic gates. Okay, I hope you can see the screen that I'm sharing with you. And so we just to recap, we have learned that there are 5 logic gates. Okay, 5 basic logic gates, which is the AND, OR, NAND, NOR, and NOT. Okay, dan, atau, tak dan, tak atau, dan tak. Okay, and every single gate has their own function. Of course, the XOR gate is an exclusive gate, it's a special gate, which you can, if you want to, but if you don't want to, so it's okay lah. When you remember lah, XOR gate is kalau dia 0 and 0 or 1 and 1, then the output will be 0. Okay, and we also know from the last lesson that all logic gates actually they are inside the logic gates are actually many transistors. They're working together to come up with this particular function lah. So the AND gate the syarat is both must be on, baru dia akan on. OR gate is salah satu on, dia akan on. Okay, tak dan is NAND gate, okay, is the opposite of the AND gate. Okay, and the NOR gate is the opposite of the OR gate. Okay, and then NOT, there's only one input for the NOT gate, so that makes it only one output lah. Okay, because the function of the NOT gate is to terbalikkan the input. Okay, so the NAND gate is kalau sepatutnya dia on, dia akan kasih off lah. Okay, so I hope you remember all the 5 gates and that the exercise that we did in the Google Classroom. I hope that you guys have no problem with it. If you do have a problem, always ask. Okay, because actually logic gates is a very easy. This whole chapter actually, of all the chapters in physics, electronics is actually the easiest. I mean for me lah. Okay, yang paling susah we all know is electromagnetism. Okay, but logic gates, especially in the electronics chapter, is actually the easiest of them all. As long as you remember the functions of the gates. Okay, so like I said, this is macam sifir lah. You have to know. Okay, you have to know and you have to remember so that, kamu nampak dia ni gate then you know how it works. Okay, so that's the key to understanding this subtopic lah. All right, so today we're going to be talking about the applications of logic gate control system. So we're going to see how one logic gate or a combination of logic gates can be used in certain control systems which we use in our life today. Okay. All right, sorry, there's still some people coming in, so I just need to. All right, so the first one is this. If you have a fire alarm system. Okay, so a fire alarm system, there are smoke sensors and temperature detectors lah, pengesan asap dan pengesan haba, okay, atau pengesan suhu. So if there is no smoke or low temperature, the alarm will not trigger. Okay, ini siren alarm lah. So kalau sini tiada, the alarm will not trigger. That's normal lah, kan? Because fire alarm system is mesti ada asap dan mesti panas, baru dia akan alarm. Okay? If there's just asap but it's not that panas kan, and if your alarm on, so then it's very susah for you to cook lah kan, susah untuk cook. So we need a system whereby dia akan tahu when it is hot dan dia berasap, most likely your house is on fire. So that's why you need to turn on the alarm. Okay, one of the inputs is high or both the smoke or temperature sensors is high, then the alarm will trigger. Oh, okay, so salah satu tinggi terus this one. So we assume, we assume that this high, high means the input is on. Okay, low temperature or no smoke, the input is 0. Okay, so of course our study is not about macam mana kita mau susun ini smoke detector supaya dia dapat mengesan inilah. Okay, that's another use of transistor in itself. But we want to see how these two, bila digabungkan dengan, what gate is this? Okay, so the moment you see the gate, you must recognize what gate it is. This is the OR gate. Okay, gate atau, sebab dia punya bentuk macam huruf A. Okay, gate atau. So gate atau, then you have to remember, okay, what's the function of gate atau? Gate atau is dia campur. Okay, salah satu on, dia akan on sudah. So let's take a look at the truth table lah. If it is 0, 0, no smoke, no heat, then it will be 0. No smoke but got heat, okay, then the alarm will on. Pretty strange though. Dia panas tetapi tiada smoke. Okay, maybe lah, can lah. Okay, ada asap dan tiada haba. Okay, then the siren will on. I guess this is how smoke detectors work lah. Kalau banyak betul asap kan, yang sangat luar biasa lah. Okay, banyak betul asap, sangat luar biasa, terus dia akan on. Okay, that makes sense also. But definitely ada smoke dan ada heat, dia akan on siren. Okay, so we find that one use of the OR gate, okay, one use of the OR gate is for smoke detector systems. Okay, smoke detector systems. Betul-betul, the two people that I said that I thought will not be here today are really not here today. So interesting. Okay, so this is one use of the OR gate. Okay, but sometimes it is not necessarily the OR gate. It can be any other gate. But this is just one example of an application. Okay, so we have a smoke detector circuit, we have a heat detector circuit, then we combine the two and let the inputs run through the OR gate. Okay, let's run through the OR gate and then we see the output that we want. Okay, so this is one application of a logic gate control system. Okay, it's a pretty simple one, use OR gates. So some applications, some control systems, they only use one logic gate. Okay, other control systems like this, they use two logic gates. Let's see how. So this is an electronic control system that is used as an automatic and manual switch to switch on the street lights when it is dark, and the control system allows the street lights either to switch on manually or by a switch at any time, or automatically by a light sensor when it is dark. So you know that this light sensor, okay, this light sensor circuit over here is the one that we studied in the previous subtopic, the one with the resistor over here. Then after that, this is the LDR, okay, and then after that over here is the transistor, yeah, okay, and then this is the, okay, this maybe goes into this one lah. Okay, then after that, over here like that. Okay, so this is what we studied the last time. So this is what we call the light detector circuit. Okay, so inside here is this one lah. Yes, you can put the street lights over here. Okay, but usually this part, okay, where the light bulb is, because it's just one light bulb. You want to control a whole series of light bulbs, right? Most likely here, okay, is the relay switch lah. Okay, the relay switch that is controlled, that will determine whether it is on or off. Okay, kalau on then dia akan melalui sini, kalau off dia akan melalui sini. Okay, so let's consider this lah. So we assume that daytime, okay, is 1 and nighttime is 0. Okay, daytime is 1, so day is 1, night is 0. Okay, this has to be assumed. So in the daytime, okay, so if it's 0 and 0, hold on, let me see. Okay, this is very strange. It should be the control system to allow manually by switch on automatically when the light sensor when it is dark. Oh, okay. Bah. So let's say this is 0 and 0. Now what gate is this? This is the NOT gate. Okay, and this is once again the OR gate lah. So 0 comes over here, tetap 0. 0, once it passes through the NOT gate, it becomes 1. So 0 and 1, because it is OR, it will become 1. Okay, so switch is off, but the light detector is at night. Okay, so it will automatically switch off. So you don't have to turn on the switch. Okay, so in the street light system, yeah, it's true. In the street light system, you can actually turn it on manually, but it is very payah lah. Okay, and you can also have it turn on automatically when it is dark. Okay, but when it is dark, over here we assume that when it is dark, it is 0. Okay, so hitam lah, hitam adalah seperti switch off the light. Okay, so it's 0. But why is there two systems lah? Kenapa ada switch dan kenapa ada automatic switch? Okay, because just in case the light detector di sini ada rosak, and then sudah malam kan, tetapi kenapa ni lampu jalan masih lagi belum hidup? Okay, so it is possible to go and manually switch it on lah. Okay, I used to stay in a place, I won't mention where. I used to stay in a place where this happens quite a lot of times. You know that dia sudah gelap kan, tapi the lampu jalan tidak on. Okay, and the good thing is there is an electrician. Either he was an electrician or electrical engineer. I can't remember. But I remember that he used to go to the control box which was near to his house. He used to go to the control box and he would manually switch it on. And then we'll be like, oh, okay, thank God. Okay, ada sudah lampu jalan. Okay, but he also said that, this is possible. Sometimes the light detector switch is not able to detect maybe something is wrong in the switch. So that's why we have two this one. Okay. Sorry. Okay, so next situation is if we turn off the switch, okay, and it is daytime. Okay, turn off switch if it's daytime. If you pass through the circuit, the output will be 0. Because obviously, switch off and it is daytime. Why would you want the street lights to be on? Right? Street lights to be off. Okay, you turn on the switch, you turn off the light sensor, or it is at night. Okay, definitely the lampu jalan will on. Okay, this is normal. But look at this situation. So this 0 and this 0 is dua-dua is at night. So we want it at night. We definitely know that at night the street lights must turn on. Okay, but the difference between this situation and the third situation is this one the switch is off, this one the switch is on. So the good thing about this combination of logic gates is that even if the switch is on, it will not affect the output. You know, dia bukan double entry means terus out. Okay, so even if the switch is on, it will still be the street lights will still be turned on. Okay, even at night. Okay, but how about this? This is daytime. Okay, this is daytime and the switch is on. Okay, now daytime, I mean usually the street lights will be off but because the switch is on, the street lights will still be on. Okay, and we use a combination of these logic gates to help us to see how. Okay, let me just show you from let me just show you this last one 1 macam mana dia dapat 1. So kalau sini 1, sini 1. Okay, so over here so flows 1. So 1 melalui sini. But over here this 1, okay, bila dia melalui the NOT gate, dia will become 0. So 0 will come here 0. So 1 and 0, 1 dan 0 melalui OR gate will come out as 1. Okay, but the point is this the susunan of this one must reflect what the question wants or what the situation wants. The situation wants is the control system allows the street lights to turn on, okay, manually by a switch or automatically by a light sensor when it is dark. Okay, and dia cakap or. Okay, so it's either dark or the switch is turned on. So definitely switch turn on kan, it must be on. And definitely light sensor is dark, okay, then it will turn on. Okay, sorry, 0 and 0, then it will turn on. So only one condition, okay, di mana the street lights will be turned off. The light sensor sees that it's daytime and the switch is off. Okay, other than that, everything will be on. Okay, that's the second one. Third one is a student would like to construct a logic gate circuit to switch on an air conditioner in his home automatically. Okay, who doesn't like that? Then automatically turn on, turn off. Okay, and if you have an aircon at home, okay, you will know that actually you can set your aircon to, I mean, our current control system is that we can do it in terms of the time. Sampai jam masa ini, okay, then it will turn off by itself. Okay, but somewhere in that remote control or somewhere in your aircon system is a logic gate that tells the aircon, sends a signal to the aircon. Okay, pada waktu ini kamu turn off. Okay, there are a few other things at play but one of the things that is at play is actually a logic gate system. Okay, so To switch on the air conditioner in his home automatically, now he has chosen a light sensitive device over here to detect daytime and night, and a heat sensitive device to detect the surrounding temperature. Now think about the situation. When do you want the air conditioner to turn on automatically? Hey, this is not an air conditioner. This is a heater. Let me see. Oh yeah, it's a heater. Okay. Bah, never mind, never mind, never mind. Let's see. But the thing is, this is a AND gate. Okay, so AND gate 0 and 0. So if this is 0, this is 0, 0, 0 melalui sini. Bila dia AND, dia akan off. The heater will turn off. Okay. I guess it's not saying here. Sorry, before this is night time, light detector. 0 is night. Okay, I think this light detector is opposite lah. Light detector is 0 is day, 1 is night. Okay, for the heat sensor is 0 is cold. No, 0 is hot. Okay, 1 is cold. Macam. Okay. Actually, the question should tell you what does the 0 and the 1 mean. Okay, cannot assume one. Sometimes, yeah, you cannot assume. But let's just try and see lah. Kita cuba and tengok. Okay, so 0, 0 will be 0. 0, 1, because dia melalui AND gate, we know that it is 1. Okay, so if this is 1, sorry, 0 and 1, because dia melalui AND gate, they become 1. 1 and 0 become, 0 here, 0. 1 and 0 will be 0, and then 1 and 1 will be 1. So the heater, very strange though, heater will turn on, okay, if the light detector is 1 and the temperature detector is 1. Okay, which is this. Okay, let's talk about this. Let's say this is a heater lah. Bila masanya kita mau heater on? Kita mau heater on apabila dia gelap dan apabila dia sejuk. Kan? That's why we want a heater. Why would you want to turn on the heater if it is daytime when it is hot atau dia panas walaupun dia waktu malam? Okay, so we want these two conditions. Dia mesti malam dan dia mesti sejuk. Okay, baru dia dia turn on lah. Okay, so according to this lah, okay, according to this, if it is a heater, okay, kalau dia adalah heater, okay, then we will say that 0 is day and 1 is night. Okay, and 0 is hot and 1 is cold. Because it must be nighttime and cold, baru dia akan turn on. Okay, dia mesti malam dan sejuk, baru dia akan turn on. Okay, does that make sense? Okay, but what if it is, okay, let's say we follow the question properly and not the diagram lah. Diagram cakap heater bah. Okay, but what if we follow the question and say that this is not heater, this is aircon. Okay, we know that the AND gate is dua-dua mesti 1 and then baru dia on. So let's think about it. When do we want the aircon to turn on? We usually want the aircon to turn on during the daytime. Okay, daytime, and kalau pengesan suhu dia adalah cold, sejuk kan? So if it is hot, sorry. Hot. Sorry. If it is daytime and it is hot, then usually we will want that to be turned on. Okay, to detect the surrounding temperature. Okay, so if we use the AND gate, okay, then we find that daytime, okay, is 1 and hot is also 1. Okay, so 1 will be daytime and 0 will be night. Okay, manakala ini adalah 1 will be hot and 0 will be cold. Okay, so the zeros and ones sebenarnya must be defined by the question. So this particular one dia ada silap sikit lah. Okay, dia tidak mendefinisikan apa 1 dan apa 0. Because it's supposed to define 1 and 0 for you. Okay. Okay, it's supposed to define 1 and 0 for you and not make you assume. But actually, we can figure this out ourselves. Okay, we want the aircon to turn on when it is daytime and if it is hot. It doesn't make sense. Now it's daytime, tetapi sejuk bah di pagi. Kan takkanlah kau mau kau punya aircon automatically on bah kan. Okay, like for example now, as I said lah, it's daytime, but it is cold. I don't want my aircon to automatically turn on. The aircon should automatically turn on if it is daytime and it is hot. Generally at night we don't want it to be turned on lah. Sebab at night dia kan sejuk. Okay. Yeah, I know those of you who sleep with aircon at night, like me. Okay, yeah, we turn it on at night anyway. But what if I want the situation to be, I want the aircon, this one. Okay, I want the aircon to turn on automatically if it is day or if it is hot. Okay, then this gate cannot be used again because this is the AND gate. I cannot use the AND gate. If I want either daytime or hot, then I will have to use an OR gate. Okay, if I use an OR gate lah, so that I will get 0, 1, 1, 1. Sama ada dia panas atau dia siang. Okay, then dia akan turn on. Okay, but the qualification is still there lah. 0 is dark, okay, and 1 is light. Okay, 0 is cold and 1 is hot. Okay? It still has to be defined for you. Hold on. Okay, 1. Yeah. Okay, so if we do that, then our definition here follows the one that we talked about in the previous slide. Okay, day is 1, night is 0. Ada cahaya 1, tiada cahaya waktu malam, dia ada input kosong, which makes more sense. Okay, all right, one last application, I think. Okay, this is a more popular application now, which is the fire control system. Okay, the fire control system has a smoke detector and a heat detector. So just now, the one that we saw in the first one is just alarm only. But now, there's not just an alarm, but there's also a fire extinguisher. They automatically akan this one. Nowadays in our system, we call it sprinkler lah. Okay, there's some offices they have sprinklers on top. So lepas the alarm bunyikan ti 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 ti, then usually the water will come down from the sprinkler lah. Okay. Saya belum lagi pernah berjumpa automatic fire extinguisher lah. Most fire extinguishers I know they are like, okay, they are manually done. But so let's consider this is a combination of two. Both the smoke detector and the heat detector must go through the AND gate. Okay, this is the AND gate, and both the smoke detector and heat detector must go through the OR gate. Okay, so let's consider first situation 0 and 0. So here will be 0, 0, 0, 0. So smoke detector 0, heat detector 0, AND gate will be 0. Okay, heat detector 0, sorry, smoke detector 0, heat detector 0 melalui OR gate tetap 0. Okay, that's the first situation. Second situation is 0 and 1. Okay, 0, 1, 0, 1, 0, 1. After the AND gate, this will be 0. After the OR gate, this will be 1. Okay, think about it lah. What situation is this? Smoke detector 0 tidak mengesan asap, tetapi dia mengesan haba. Sprinkler will be off, but the fire alarm will be on. Okay? So no smoke, got heat. Fire alarms, yeah, because maybe dia just panas sebab, panas lah. Okay? But there's no smoke, so there's most likely no fire. Okay? Third situation. Third situation is smoke detector 1, heat detector 0. This is strange, but it's possible. Okay, ada asap tapi tidak panas. So 1, 0, 1, 0. So here will be 0. Here will be 1. It makes sense because ada asap tapi dia tidak panas. So it's like, should we turn on the fire extinguisher? What if it is not fire lah? It's just smoke, but maybe it is smoke from cigarette kah atau smoke from this one. So, doesn't make sense to turn on the sprinkler yet lah. Jangan dulu pasang this one. Okay, and the final situation is ada asap, okay, dan ada haba. So 1, 1, 1, 1. N will be 1. Or also will be 1. So definitely ada asap dan ada haba, definitely fire alarm will turn on lah, so they all get. And the fire extinguisher will also most likely turn on. Okay, because ada asap dan ada haba kan, most likely is because your office is on fire. Okay, so that's how this will look like 0001 and 0111. Okay, so we assume, we assume that 0 means, okay, ada asap, okay, or 0 means ada heat. There is heat lah. Okay, 1 is no smoke. Sorry. 0 is no asap. Aish, what's wrong with me today? 1 is no smoke and 1 is hot. Okay, so that will make sense in this system. Okay, but now the thing is this lah. Okay, for this particular section, yes, you should know what the logic systems are lah. But I have not seen lah. Saya belum lagi nampak. Actually, I have, but not in SPM lah. I've seen it in trial questions. I have not seen a question that asks you, okay, to design your own circuit. Okay, and then kau kasih gabungkan this one lah. Okay, I have seen they will give you the logic gates, okay, and then they will ask you to design the circuit. But that's a trial question. I don't think I have seen it in an SPM real question before. Okay, what you should know is if I give you the circuit, you should know how to come up with the truth table and explain what happens from the truth table. That's the important one. Okay, if I give you the circuit, let's say saya bagi satu circuit kosong macam ni kan, you should be able to first of all tell me what is the output, okay, in each device, and explain to me what is going on. Okay, and that's why it's called logic gates. This is very logical. Yeah, it's very logical. It's only 1 and 0, on or off. Ada atau tiada. Itu saja. Ada haba, tiada haba. Okay, ada api, tiada api. Ada asap, tiada asap. Okay, that's it. Day or night. Okay, most likely is that. Okay, so that's it. That's the end of our syllabus. Yeah, that's the end of our syllabus. And I just want to end by discussing one example question. Okay, that involves this one. Okay, I'm going to discuss this here, but I'm going to give you this handout in your group later lah. Okay, so diagram 7.1 shows the resistance against temperature graph. So the resistor, temperature for a thermistor. Okay, just to remind you, thermistor. Okay, thermistor is a heat sensing resistor. Okay, heat sensing resistor. So when the temperature is low, resistance is high. This is the normal one. Okay, bila dia cold, then resistance will be high. So state how the resistance of the thermistor varies with temperature. Okay, this is basically nyatakan hubungan antara rintangan thermistor dengan suhu. So this will be the bigger the temperature. How? The bigger the temperature, the smaller. Okay, or the lower the resistance. Okay, just to remind you how to write hubungan okay, state how the resistance varies with temperature. This is also another way of asking you to write the relationship. Okay, yang sudah kita belajar balik-balik sudah saya cakap, the bigger the smaller the. Remember, only 4 words, bigger, smaller, higher, lower. That's it. Or greater, lower. Okay, don't use hotter lah, tabau. No hotter. I don't want to hear the word the hotter the temperature. Okay, what is the resistance of the thermistor at 30 degrees Celsius? Show on the graph. Okay, so you have 30 degrees over here, then you show low. Okay, then you read. So you read. Okay, so it's about 1.4. Okay, 1.4. Follow the unit on the graph, which is ohm. Okay. I'm going to discuss this question now. Later, I will give you this same handout. I will give you lah. Okay, then you can answer the questions on your own. All right, this is the one I'm talking about. So a thermistor and a light-dependent resistor are used to make a simple switch, okay, which controls an aircon in the room as shown in diagram 7.2. So take a look at this. Okay, so input P, now during the day is logic 1, okay, turn on. During the night is logic 0. Okay, so take a look at this. This is the, itu saya cakap, ini adalah condition dia mesti bagi. Input Q, when it is hot, okay, it is logic 1. When it is cold, it is logic 0. Relay switch, it will switch on when the output logic is 1. Kalau sini adalah 1, okay, dia akan on. Kalau sini adalah 0, dia akan off. Okay, so the question will be usually this lah. Using the keys given, complete the table 7. 0, 0, 0, 1, 1, 0, 1, 1. Ni kita belum lagi tahu what gate. Okay, we don't know what gate it is, but dia cakap macam ni ya. Okay, we need to see the logic is 1, this logic is 1, then this will be turned on. Logic is 0 will be turned off. Okay, so let's consider first situation. Sini 0, sini 0. Okay, so 0 over here on the LDR is night. Okay, sebelah night, and 0 over here is hot. Okay, what do you think? The aircon will be on or not? Yeah, I know. It can be interesting. Okay, do you want the aircon to turn on or not? Actually, you can be both ways, you know. But to make a which control the air conditioner, yeah. The air, okay, so this is the syarat. The air conditioner is only activated either on a sunny day or a hot night. Okay, hari yang panas, waktu siang yang panas, okay, atau malam yang panas. Okay, so what do you think? Will this be on or off? 0, 0 is at night, and 0 thermistor is cold. Oh, 0 is cold. Okay, so this will be 0. On ah? Really, man? LDR 0. Hot night. Hold on. LDR 0. This is light. Light 0 is at night. Okay. Thermistor 0. Thermistor 0 is cold. Oh. So this is a cold night. Oh. So P is 0, right? Okay. So P is, let's put this night, night, day, day. Okay. Q, cold is 0, hot is 1. So cold, hot, cold, hot. Oh. Did I write hot night now? Oh dear. Did I write hot night? Yeah, hot night lah. Oh. But this is 0. 0 is cold night. 0 is cold. Okay. That's why I say lah, these conditions must be given. You are not expected to know, okay, at your level, you're not expected to know what is 1, what is 0. And even if you're supposed to know, it is possible to change. I can change 1 is cold and 0 is hot. Saya boleh ubah. Okay, it depends on how I set my thermistor lah. Okay, so it can be changed. But now the condition is this: 1 adalah panas, 0 adalah sejuk. 1 adalah siang dan 0 adalah malam. Okay, so let me just check. 0 malam, so night, night, day, day. Cold, hot, cold, hot. 0 is cold, right? Okay, so night and cold. Do you think my aircon will be on? Obviously not lah. Okay, automatically it won't be on lah. Because it doesn't make sense. Why would you turn on? If you turn on, kalau kau turn on your aircon at night bila dia sejukkan, then you're exactly like me. Okay, what a waste of time. Okay, night and hot will be turn on lah. Day and cold. Okay, what do you think? Day and cold. Pada waktu siang dan pada... Okay. Let's see. Off, off, off. Okay. Now, I'm just going to take a step in the dark. This is probably turned on because it's daytime. Okay. You know why? Because of the word orb. Okay. This word over here, okay, this word over here is actually very, very, very sana. Okay. If you read the Malay one, penyaman udara akan dihidupkan pada waktu siang. Then dia cakap di sini dan tau, which is like, okay, pada waktu malam yang panas. Okay, padahal yang bahasa Inggeris is sunny day or at a hot night. So it's like, mana satu ini? Okay, satu is all, satu is done. We always follow the English lah. Sunny day or a hot night. Now I'm thinking sunny day. Sunny day means daytime. Doesn't mean that sunny day is hot. Okay, so I would say that this one the output is 1. Okay, asalkan dia siang dia akan 1. But of course, this is daytime and it's hot, definitely will be 1. I would say this lah. Okay, so we find that we find that by some strange way lah. Okay, 0, 1, 1, 1 is our output. Okay, so in order for us to get this, our logic gate here should be what? Our logic gate here should be the OR gate. I can sense banyak orang membantah sudah ni. What is this? What nonsense is this? Okay, yeah, I know. Okay, this is the fault of the question lah. Okay, because yang bahasa Inggeris begini, yang bahasa Melayu begini pula. Okay, but let's just think about it logically lah. Okay, because okay, let's say lah, what if this answer is 0 lah, yang kamu cakap lah, yang berbalik-balik kamu cakap lah, 0, 1, 0, 1. Okay, sebab kau cakap, oh dia kan sejuk, jadi buat apalah kamu ni? Sebab dia tidak memenuhi syarat ini, dia sunny day. Dia bukan sunny day, dia adalah cold day. Now, if your answer is 0, 1, 0, 1, then what answer are you going to put in number 2? Because there's no logic gate that tells us 0, 1, 0, 1. What we have learned is 0, 0, 0, 1 or 0, 1, 1, 1. So if they mention OR, does it directly? No, it does not directly refer to the gate lah. But that's a very good clue, actually. Yeah, it's a very big giveaway lah. The only problem I have with this question, and that's why I wanted to discuss this, is you look at the BM and the English version. English says OR, and then the Malay says done. So if you're answering this question in Malay, you would probably answer END gate, because it makes sense at END gate. Siang dan malam yang panas. Kan? Dia mesti siang. No, siang dan malam yang panas. So this is what I will get now. Siang dan malam yang panas is I will get 0, 1, 0, 1. And then there's a problem. Because what gate is 0, 1, 0, 1? You don't have. You only have 0, 0, 0, 1. This is AND gate. 0, 1, 1, 1 is OR gate. What is the other two? Self-made gate. Yeah, Ethan, self-made gate. Okay, the other one is 1, 1, 1, 0. This is NAND gate. Okay, and then 1, 0, 0, 0. This is the NOR gate. Okay, NOR, right? Yeah. These are the only 4 outputs that you know. So what the heck is 0, 1, 0, 1? Nobody knows what 0, 1, 0, 1. Okay, or even if this 1 and 0 would change, 0, 0, 1, 1. Tiada dalam kamu punya syllabus. So if you were answering this in Malay, then this would be a big problem. Okay, because because there is no answer for this 0, 1, 0, 1. That's why I said if we follow the English, okay, this will make sense lah. Either daytime atau panas. Okay, so the logic gate here will be this one. Now draw the symbol of the logic gate. Okay, that's why I said you need to know the symbol, because this is a commonly asked question. You need to be able to draw the symbol of this one. So the OR gate looks like the letter A. Okay, 2 inputs and 1 output. Okay. Yeah, it doesn't have to be this sharp lah. I know the gambar raja looks like macam bulan bahkan. Okay, macam bulan. Bah. So I think this is the last part of this question. So this is another one, but this is a transistor circuit lah. Okay, what is the function of the resistor R1? I think this is something that you answered previously. Okay, so what is the function of this resistor is to increase resistance of base circuit. Okay, the function of R1, okay, not this one. This is, what is this? What is this tool called? This is called the potential divider circuit. Okay, so the function of these two resistors is to divide the potential, to divide the voltage lah, or the potential difference. But this function of the R1 is to increase the resistance of the base circuit, so that this LDR doesn't have to work so hard. Because remember, this circuit, the transistor can only turn on kalau the resistance here is high enough. The resistance here is high enough, voltage will be high enough, transistor switch on, the collector circuit, blah, 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 blah. Okay, balik sudah saya cakap. So the function of the R1 is dia macam booster bah. Okay. Sini memang cukup tinggi sudah, tapi kita kasih boost sikit lah. Okay, so that the LDR doesn't have to work so hard. Okay, to increase the resistance or to increase the voltage. Okay, so that's the function of the resistor R1. Explain how the circuit functions at night. This one, you have done this. At night, this is high resistance, so high resistance, transistor switch on, blah, 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 blah. Okay, ini kamu sudah belajar. Now, why is the lamp not connected directly to the transistor circuit? So why is there a relay switch? Okay, I just want to mention this because this is another version of what is the function, okay, of the relay switch, which I discussed in my previous class. Okay, in my previous class, I talked to you about the function of the relay switch. Okay, but this is the same question, cuma dalam ayat yang berlainan. Why is the lamp not connected directly to the transistor circuit? Okay, because it's connected to the relay switch so that blah, 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 blah. Then you state there the function of the relay switch. Okay, as I mentioned in the previous subtopic, sorry, not the previous class, previous subtopic. Okay, so I just wanted to discuss this question just to show you these two things, the function of the resistor R1, because I don't remember whether I covered this in the transistor question. And then the second one is to talk about this question, which is basically asking the same thing, cuma dalam ayat yang berlainan. All right, so that's it. That's our entire syllabus in a nutshell. And we have finished this syllabus for your physics SPM. So that's it lah. No more lecture. Yay. Okay. I hope that you guys were able to learn something despite the rain today. Yeah, it's pretty rainy. Yeah. So I'm going to stop the recording now.